Hi, everyone. My name is Monique. I hope you're enjoying the conference. I'm happy to be here and talk about how to build data products in a fast-paced environment. So today I'm going to share my experience working in cross-functional teams and some of the lessons and learnings that I had building data products while I need to quickly adapt to changes in the requirements and demands. Before we jump into the presentation, I would like to share more about some information about me. So my background is actually in finance, and I've been working transition to data science because mostly my passion about how to use data in different ways. I've been working with marketing consultancies and projects with blue chip companies on how to apply AI techniques to solve real problems. More recently, in the last years, I have been also experienced shifts in how we work, and I would like to share that with you. Today, I'm working as a senior data scientist at Trustpilot, building, designing data products and improving customer experience. More about Trustpilot. So Trustpilot was founded in 2007 and with a vision to create an independent current of trust. It's a digital platform that connects consumers and business. So we help business to shop with more confidence. At the same time, we provide actionable insights to businesses. We are in different 10 locations. We have more than 167 million reviews, more than 700 websites reviewed in the platform, and more than 50 nationalities working at Trustpilot. Yes, and to give more context about my role and the team, I work at the data science products and insight teams, so across all the products. And as I mentioned, both from business and consumer part, we work cross-functional teams to improve and to design those features and data products. So my experience and some of the learnings that I'm going to share comes from the business side and can actually be easily applied to any scenario and any team. So I hope you enjoy. So to start off, let's talk about data products and how it's actually some of the elements that we need to consider. So let's start with the customer pain. So we think about customers' problem, what we wanted to solve. We also have our data characteristics, so the data that we produce in-house, the raw data, right? And then we also have the value that we can add to this data. So basically how we can enrich this data to make it actionable. Before we jump into more details about the workflow and how the development process actually takes place, I would like to share some statistics about those projects. So according to Gartner, only actually 20% of this and the analytics insights will deliver business outcomes, which is quite alarming. And it's actually a little bit worse, as 85% of all big data projects fail. And you are probably wondering why. There are so much investments in time and resources. So why? What are the reasons why most of the projects fail? And I highlighted the most, for me, interesting reasons for that. So most of them, in most cases, we're trying to solve or not identifying the right problem. We are not actually adding value. Another interesting reason we think about deployment in the last step, in the last phase of the process, or simply it's a problem of the process itself. There is no process, or we are just doing a wrong process. That's quite interesting item, and I would like to focus on giving more insights on the process. So if we look at the data product and development workflow in a general way, we have the first steps of talking to customers, understand the problem, identify our audience, our target audience. And then we quickly try to work on a solution, create a prototype, getting feedback from the team, from stakeholders, and implement the solution. And then we iterate a little bit more until we are happy with that. And then finally we launch the feature, the product, and then we start over. So what can actually possibly go wrong in that? I would like to highlight a couple of things. So in the first phase, talking to customers, it is quite interesting that we sometimes assume that we know what the problem is, and we just jump into the next phase and building the solution without really understand what the problem is. Or we have some assumptions what the customers want, and we just jump into the development phase, the prototype phase, too soon. Other reasons also the prototype and development phase that I would like to give as an example, also as a result of not really understanding what the problem is. So lack of requirements for the prototype phase, or very customer requirements, as well as when implementing the solution, we end up with a problem, technical problems, integration issues, or we figure out that actually it is more complex than we estimated in the beginning. Common issues also related to dependencies to other teams, and all these problems cause this part to actually take longer than estimated. So if we look into what the roles and people involved in this process, usually what we see is that customers that are represented by project managers that talk to customers, UXers, designers, marketing teams, sales, customer success teams, they are heavily involved in these phases, right? And while in the prototype phase, you see more development teams, so engineering, data science, data analysts, machine learning engineers as well. And then also in the implementation phase, the development team. And then finally, when we launch the product, then we have the marketing, all the communications, the release process, right? But if we think the challenges that we had, and how the roles are traditionally involved in this process, can we make something out of it? Maybe can we change the way that we work so we solve some of those challenges? So I propose actually a new way of working. So if we think about all the people involved initially that with customers and identifying the problem, it is not really a big shift, but in this slide, what I'm proposing is actually we are all involved in the process, but we contribute in different ways. And in some of the steps, we contribute more. In other steps, we contributed in different ways, as for example, giving inputs So now you might be wondering, okay, so in the prototype phase, development phase, how the other roles can actually contribute? And I would like to give some examples because it's actually a very difficult question. So for example, in this phase that the data science, for example, working on the prototype, it is quite helpful to have some feedback, even in terms of we are choosing the right metrics to measure success, or even we are to keep track of any integration issues, so we can make sure we reach our deadline to launch the product, to launch a new feature. And at the same way, for engineering and the data teams, how can they contribute to the other phases that usually they are not so active? So in the first phase, for example, data science and data analysts, they can help through data, validating, for example, personas, or identifying market trends, and providing more information to stakeholders, so we can actually understand the business and the customer problem. And as well as the last phase, data science and data analysts and also the team itself can be involved as listening and helping with some questions, or understanding why customers are having questions on what exactly they have questions. So this is actually a way to be involved through the whole process. And yes, so as I mentioned before, data science work is data science can be actually quite active across the whole process, across the whole development process. And but I would like to go a little bit deep into the details how this works in practice. And I think it is also a good opportunity for professionals outside the development, the technical area, to understand how they can collaborate with the data science, and how actually data science is used in different steps. So I would like to start with a problem statement, right? So if we think more about the Trustpilot, business receive tons of reviews on a daily basis. So how can we translate all those reviews, all that data into actionable insights? So we have a given problem to solve. So the initial phase, as I mentioned, is understanding the problem, understanding who is this customer, right? And the traditional methodology to understand, we interview customers, we create personas to understand their journeys, which way to understand the reasons why the customers have that problem, and through customer surveys and through customers interviews. And finally, we try to come up with a solution, how to solve that problem. So what I would like to share is how data science can contribute to that. And from the data science perspective, we can actually help by looking to the data, exploring the data, understand if there is any partners in data, if there's any relationship with location, languages, customer-based segmentation, establishing these correlations and partners, and helping UXers to understand, and as a team understand the problem. Also, in the ideation session, usually with the team on trying to come up with solutions, data science can be quite helpful on providing stakeholders early assessment and insights on what the data that actually we have available, and identify potential actually red flags with some solutions that we brainstorm. And what I would like to have just as a note, as a side note, especially for technical members in the team, we usually jump into, and I can include myself on that, we usually jump into the solution mode. I think we tend to think about how to solve the problem, and sometimes thinking too much into the solution and forget about the problem. And it is quite important that we focus on the problem instead of just jumping to the solution, or how to actually build a solution. So going to the next step, that is the prototype phase. So a prototype is an early sample model or release of a product that is built to test the concept that we're trying to build. And it is typically used to validate the product design or functionality and gather end user feedback before deploying that into production. That is usually a common definition of a prototype for software development. And I would like to challenge that today by how we actually see that in data science, building data products. So when designing the solution and exploring approaches, I would like to highlight 4 elements to that. First, it is scalability. So during the prototype phase, we usually use a sample of the data, our customers. So how does it work actually if we wanted to scale that to all customers? So when thinking about the solution, the model, the approach, it is quite important to think about scalability. Also explainability, and I like this one. It is basically the bridge between the technical part and the non-technical audience. So how can you explain your model? How can you explain the outputs of your model to, for example, non-technical audience? Another one, the third one, is implementation. So here you should consider the challenges of the chosen approach when implemented that to the product. So you can think about the technology stack, how is difficult, how complex is to implement this approach to the current architecture. Flexibility is about changes will come. We don't know when, but they will come. And then you need to have that in mind when choosing your approach. I will go through some examples in the next slide of all these 4 elements. But before that, I would like to highlight also in this phase of creating a prototype, it is quite important that we have in mind how to validate our approach. And I like to think about that in 2 different ways, 2 different categories of metrics. So we have the technical metrics that can be related to the machine learning metrics that you use usually, like precision recall, more technically, and that's also business metric. So how your model, the output of your model approach will impact the customers. So we can talk about coverage, how much of the customer base your feature will impact, how. So the changes that it will promote when deployed to production. So some examples of the 4 elements when choosing your approach in data science, when creating a prototype. I would like to go through some examples of how this works in practice. So when it comes to scalability, as I mentioned before, So is your approach, is your model, your algorithm, is it able to scale to when deployed in production? Is it able to scale to all customer base? When it comes to explainability, the chosen approach should be able to explain the model output to non-technical audience. Remember that we are building products to different audience, and you need to understand your audience. So your model should be able to speak to them. And also for the data science perspective, the model output should be easy to understand. So data science have a good intuition on how interpreting them, how to improve, how to correct them when something is wrong. On the implementation side, we need to consider the current architecture, as I mentioned before, when choosing the machine learning approach, how the model outputs, for example, will be consumed in that setting. Data structure, how it's related to the current technology, latency. So those are a couple of examples that you should consider. Flexibility. So consider machine learning approach that allows you as a data science iterate quite easily through time. Part of that is the approach, the model, and part of that is also how mature your development process, your current tech stack. For example, your machine learning engineers are helping you to create a pipeline that can automate process, so you can deploy experiments faster, quickly. So all that goes into flexibility. So flexibility on how you build, but flexibility also on the algorithm behind it, how easy it is to change something. Let's say that's okay. We are finishing with the prototype. We implemented the model to the product stack. We launch new releases out. That is great. So are we finished? Is that it? Well, no. Usually we have phase for customer feedback. And we expected to have feedback from different customers, so different opinions about the same feature. So some customers can be quite positive and actually validating what you built. Other customers can have different reasons. They don't like the feature, don't think that's useful, that's not exactly what they want, or they have actually additional requests. So from the feedback, a couple of examples that I put in the slide, it's quite easy to see that it is not only one reason. We can see that actually customer feedback goes from the user interface issues to communications, to data science model, to engineering problems. So how to proceed? It is important that we understand the feedback. So we ask why. So why, for example, a customer is asking this new feature, why is important, why is critical for them, trying to understand the reason behind the feedback, and then working as a team, prioritizing and improving the product. And now you may think, oh, yes, but how data science and the engineering team can work together in the same sprint? We work quite differently. Retraining a model, it is not the same as fixing a bug sometimes in the UI. So it can take different there are different requirements for that. And there is no a right answer here, but one of the learnings that we had is that for short term, so what we consider bug fixes, from a data science perspective, two of the elements that I mentioned, flexibility and how we implement it, actually allow us to quickly make some changes. And so we can keep up with the demands and the critical things for the short term. In the medium term, for example, when we think about the next release, it is important to have in mind as a data science that some improvements we can identify areas of improvements from the data, so from your metrics, but it's also important to listen to stakeholders. They have the domain knowledge, and it's important to consider that, but also important to validate that through data. So we receive a feedback, it is important to customer. It is also, we can also find in the data, we can also validate through data. Yes, then we can implement it. Also, as I mentioned before, the scalability is also important to have MLOps in place. So being able for scalability and also for flexibility, being able to have a retraining process and pipeline in place, it is quite important from a production setting. And also, it is important to say no sometimes to very custom requests. And this is important also for engineering teams, that we cannot just implement it every single feature that customer requests, but also for data science, I would say that's quite important. So we don't prioritize or we don't favor some segments or business by implementing some custom requests and custom features. Yes, and I would like to actually just recap with some key takeaways. So as a team, it is important that we work all together and focus on delivering value to customers. It is easy to get distracted with bugs, with the different requests, but it is important to have in mind the customer pain and the customer problem. Also, get yourself involved in all steps. As I mentioned before, of course, we are more active in some steps more than others, but it's important to understand that what you do as a data science, as an engineer, as a UX, or in marketing, promoting the product will be impacted by what your colleague is doing. So it is important that we work all together. For data science, I would like to highlight a couple of things. So ask for feedback in all phases. In the early feedback is quite important. So if you have an opportunity to ask for feedback to your colleagues, engineers, to other data science, ask for feedback. Prioritize the approach that creates value for customers. It's quite easy to be seduced by state-of-art models and complex models, but sometimes they're difficult to implement or to understand. So again, the explainability element here. So keep in mind scalability, explainability, implementation, and flexibility when choosing your approach. And be aware of the trade-off performance and time. We tend to aim for perfection and improving, and we can actually spend a lot of time on that. So it is important that we draw the line when it's enough, so we can actually focus on what is important to customers. And I would like to thank you for your time. I hope that some of the learnings I share today are useful to you and your team, either you're in data science or in any other position. So thank you for today, and I hope you enjoy the conference.